Hi everyone, welcome back to our series. Hope you're doing good. This is Mahesh. In this video, we will look into LeetCode problem number 31, next permutation. So let us look into the statement of this problem. So it states permutation of an array of integers is an arrangement of its numbers into a sequence or linear order. For example, array 1, 2, 3 is given. The following are the list of all permutations that are possible. Basically 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Then the next permutation of an array of integers is the next lexicographically greater permutation of its integer. So this is very important. So more formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. Okay, so if such arrangement is not possible, the array must be arranged as the lowest possible order, that is sorted in ascending order. Okay, they have given few examples. Then they have also stated that the replacement must be in place and use only constant extra memory. Then the constraints, the length of the nums array ranges between 1 and 100 and the number in the nums array will range between 0 and 100. With that, let us switch to our editor and let us try to understand the problem. So now let us consider this particular array 1, 2, 3. So now what we will do, we will rearrange all the elements in this particular array in all the possible ways. So if we do that, then what we get 1, 3, 2. Okay, then we get 2, 1, 3, then 2, 3, 1, then 3, 1, 2 and 3, 2, 1. So these are all the possible combinations. Now what this problem states, they will give any one combination. Maybe they will give 2, 1, 3, then they will ask for the next possible permutation. So if they give 2, 1, 3, then 2, 3, 1 will be the next permutation. So now if you see here one thing, now we have got all these numbers which are rearranged, and if you see 1, 3, 2 is greater than 1, 2, 3. Now if you see 2, 1, 3, it is greater than 1, 3, 2. If you see 2, 3, 1, it is greater than 2, 1, 3. If you see 3, 1, 2, it is greater than 2, 3, 1. So this way they are ordered in a lexicographical order, and in that if they give this particular combination, then we will have to return this particular combination. If they give this one, then we will have to return this one. So this is what the problem states here. So with that, we have also understood the constraints. So basically our array length will be between 1 and 100. Okay, so this is the problem statement. So if this is the case, then how to solve this problem? So if we consider the extreme naive case, maybe before that what you can do, you can pause the video, you can think for any possible solution. Then you can come back and continue watching this video. With that, let us also try to understand the idea or what the interviewer will be expecting. So basically they will give any one array and they want us to return the next possible permutation, and that they want us to do in O of n time complexity and without using any extra space. So basically O of 1 space complexity. So that is the most optimal way to solve this problem. We will look into that later. But before that, let us try to understand what is the brute force solution for this problem. So we already seen, right? I mean, if any array is given, we will try to find all the possible combinations. Okay, then we will sort them. We will sort them in their lexicographical order. If that is the case, then we will get this entire array. We will get basically all the combinations of array. Then we will find which array we want to get the next element. So for this one, this will be the next combination. So we will search linearly for our given combination, then we will take the next combination available. So if we want to do this, then here what we are trying to do, so we are trying to generate all the possible combinations, all possible combinations. So if that is the case, if there are n elements, assume if there are n elements in the array, then to generate all the possible combinations, we need order of n factorial. So if you see, because see here we have three numbers, n will be 3 and n factorial will be 3 into 2 into 1, which is 6. So now we have generated 1, 2, 3, 4, 5 and this is the original combination, which is 6. Okay, so we basically generate, or we basically solve this in order of n factorial, so which is a costly. So this is a small example which contains only 3 numbers, but if you see in our solution or in our problem statement, basically it contains maximum 100 elements in the array. So if we consider 100 elements, then it will be of 100 factorial, which is close to 10 raised to 157 or more. So this is a very costly algorithm just for 10 numbers in the array. So if you consider more numbers, then it keeps on growing like anything. So that's where this solution is not the intended one. So you can simply say, I mean, for the interviewer, so this is a very naive solution for this particular problem where we generate all the possible combinations. Then we will take the next, we will sort it after that. Then we will search for our given combination and then we will simply take the next combination. So it takes of order n factorial, and also if you see, it also consumes extra space. It also consumes extra space. That's why it is not recommended solution for this particular problem. So if that is the case, then what is the optimal solution? What is the optimal solution? So now for the optimal solution, what did we see in the problem statement? We should not use any extra space and we should solve this in single iteration. Okay, so if that is the case, then how to come up with the next possible permutation? So let us take a small example. Okay, let me take 1, 1, 3, 2. Okay. Now we have this particular example, right? We know what is its next possible number, I mean basically the permutation. So basically that will be 1, then 2, 1, 3. Okay, so this is the next possible permutation, and this number, if you see, it is greater than 1, 1, 3, 2, but it is the smallest of all the arrangements which are greater than 1, 1, 3, 2. Okay, what I am trying to say here, if you see this example, now if you see 1, 3, 2, it is greater than 1, 2, 3, correct, right? But we have 2, 1, 3 which is greater than 1, 2, 3. This is also greater, this is also greater, this is also greater. But only thing is, this is the least possible greater number than 1, 1, 1, 2, 3. So if that is the case, this becomes our next permutation. So in the similar case, this will be the next possible permutation because it is greater than 1, 1, 3, 2, but it is the least of the greater numbers in this case. So now the solution for this problem will be kind of like, we will have to observe, I mean, what exactly we get. So basically now if I try to only rearrange last 3 and 2, then what is the number I get? 1, 1, 2, 3. Now if you see 1, 1, 2, 3, it is smaller than 1, 1, 3, 2, correct, right? Then it won't be the next possible permutation. Then these two numbers we have already utilized. If it is not possible with these two numbers, then we will have to consider these three numbers, correct, right? Anyhow, with the last single number, we cannot do anything. So we considered 2 initially. Now we will consider 3 numbers. Now with these three numbers, what I will do, I will keep 1 as it is, first one. Then 1, 3, 2, I will try to rearrange. I can rearrange something like 1, 2, 3, correct, right? But this is not greater than 1, 1, 3, 2. If that is not the case, then what I need to do, I need to check if I can take 3. So I will take 3. Then if I take 3, then 2, 1 are remaining, correct, right? So now if you see 1, 3, 2, 1 is greater than 1, 1, 3, 2. Okay, so it might be the answer, but wait. Now we will see we took 3, but there is also possibility that we can take 2, correct, right? So what I will do, I will say 1, 2, 3, 1. So this is greater than 1, 1, 3, 2, but it is lesser than 1, 3, 2, 1. So it cannot be my answer. So this can be my answer, correct, right? Now, if that is the case, is it my answer? Let's see. Now, here I took 2. I cannot take 1 because if I take 1, again it will be lesser number. That we have already seen here. So now if that is the case, I will leave this number. Next, I will play with the remaining 2 numbers. So we got this value 1, 2, 3, 1. It is greater than 1, 1, 3, 2. Okay, so now I played with this value. Now I will try to play with remaining these 2 values. Now I have 3, 1. I will simply make it as 1, 3. Then I will say 1, 2, 1, 3. Now if you see, this 1, 2, 1, 3 is less than this particular 1, 2, 3, 1. Correct, right? But it is greater than 1, 1, 3, 2. So it means this can be our answer, but this cannot be. Initially we assumed this can be our answer, but that is also not the case. So this is the possible answer now. So which is what we are looking for, correct, right? How we arrived at this one. So basically what you need to observe. So initially I tried to play with one number, but that really did not work. So I played with 2 numbers. Okay. So here I will say I tried to play with one number because we cannot play with one number. So we played with 2 numbers. Then if we didn't get whatever was intended, then we try to play with 3 numbers. Now, one thing what you can observe is, if you see the second number and the first number, from the last I'm talking about. So this number is smaller than this number, correct, right? So this number, third number is smaller than this number, but 3 was greater than 2. So where did we actually replace our number? If you see at this particular place, right? So what I'm trying to say, from here somewhere it was 2, then it went to 3, correct, right? Then suddenly there is a drop from 3 to it came to this 1. So we need this particular drop point. Why? Because that's where we replaced the value, correct, right? We replaced 1 with 2. So now one more thing what we need to observe, how did we replace this number? Basically this was our 1. So if this is our replacing number, I replaced it with 2. Then with remaining 2 numbers 1, 3, I placed them in their increasing order. Why? Because I wanted to get the least possible number. That's where we need to sort them in the ascending order and then we need to place them. Okay, so let us look into this particular example so that it will be more clear. Now what I will do, so basically I will start processing my array from the end. So I will check this first number. So this is 1. Then I will start from this particular number. Okay. So now if I start from here, 3 is greater than 1, correct, right? This is my observation. So then these 2 are in their right position. Now I will go to next number. Now 5 is greater than 3. So if that is the case, they are in their right position. Okay. Now I'll go to next number 6. So again 6 is greater than 5. So it means all these are in their correct position. Now I will go to next number. Again 7 is greater than 6. So all these are in their correct position. Now if you see, this is my 4. So from 7 there is a drop to 4. So it means this is our drop point. Okay, so this is where our number got dropped from a larger number to a smaller number. So now if that is the case, we will have to somehow keep a reference of this drop point. Okay, this is our drop point. So this is one thing. This is the first step. This is what is my observation. Now after this, once here, when I get this drop point, then what I did, I scanned the remaining elements for the number which is slightly greater than this particular number. So here I got 1, but 2, if you see, it is slightly greater than 1. It is the least greater number compared to 1. So that number I took, and then what I did, I swapped it with my 1. So now what I will do here, I will scan from the right again. So here 1 is not greater than 4, correct, right? So I'll ignore. So assume if we try to replace this with 1, so this number will result in a smaller number. So that's where we should not consider the smaller number. Next, if you see 3 is again lesser than 4. So if you replace this with 3, again this entire number becomes less than the existing number. So I will go to next number. Now if you see, we get a number which is slightly greater than 5. Why I am scanning from the right? Because if you see, the numbers are in their increasing order already on the right. That's what I am using. So I'll scan from here, here, here. At this point, I get a number which is slightly greater than my drop point number. Okay, so now I will mark this with my replacing number. So I will simply mark this. This is replacing number. Okay, now once after this, I will simply swap these two. So I will simply swap 4 and 5. Okay, so what I will do, I will swap 4 with 5. Okay, is this done? No, it is the greater number, but it is not lexicographically greater. So what we did, what we saw, we will have to arrange these elements in the ascending order. Currently, it is in the descending order, right? So it is in the descending order, but we want that in the ascending order to get the least highest number, correct, right? So if that is the case, what I will do, I will change all these and I will say 1, 3, 4, 6 and 7. Now I will keep these remaining numbers. So this becomes our lexicographically the next possible permutation. Okay, so this is how with single iteration we come up with the next possible permutation. So step 1, what we did, step 1 is find our drop point where it is dropping. So that is what we did. Then step 2, what we did, find number slightly greater than the drop point number. Okay, after that swap these two. Third step is swap. Then fourth step is simply sort them. So instead of sorting, what we can do, since they are already in their decreasing order, we can simply swap them, correct, right? So swap 1 with 7, 6 with 3 and 4 is 4 with 4 anyhow. So we can simply reverse the remaining numbers, only these numbers, not the entire array. Okay, so this is how we do. So now assume there is a corner case where we have the given array something like this. So whatever the possible combinations you take, this becomes the maximum number, right? Why? Because the numbers are in their descending order, correct, right? So, and if you try to find the drop point, you never find, because always from 1 to 2 there is increment, 2 to 3 increment, 3 to 4 increment. So you don't get the drop point only in this case. So in this case, what we need to do, we need to return the reversed array, because this is the least possible number after rearrangement. So we can simply reverse this particular array and we can return it. So with that, let us also try to understand the time complexity. If you see the time complexity here, what we did, to the max, we process in the worst case the entire array from right to left. Okay, there is only one iteration, and whatever the swapping and the reversing, whatever we do, everything we do in place. So if that is the case, our time complexity will be order of n for this case, and space complexity will be of order 1 because we don't use anything extra. So let us look that in the code now. With that, let me switch to the editor. So I will take a variable constant n will be length of our nums array. Okay, then I need a drop point variable which points at the drop point. So I will initially assign it with -1. Why? We will get to know soon. So now what I will do, I will start from the right, that is n-2 value. Then I will move towards left to get the dropping point. So I will start from I. So basically let I equal to n-2, then I greater than or equal to 0, I minus minus. Okay. Then what I will do, I will check whether there is a drop. So if that is the case, I should check nums of I. If nums of I is less than nums of I plus 1, then there is a drop. If that is the case, then we got our drop point, correct, right? So I will say drop point equal to I. Then I will simply break from here because I should not continue after this. Okay, so this way I get my drop point. So this is our first step. Okay, this is our step 1. So get the drop point. I will format it. So now what we need to do, so we discussed, right? I mean, if there is a corner case or if there is no drop in the value, that we need to check. No drop case, no drop case. So if there is no drop, it means our drop point will still be -1. So this is why we need to set the drop point value to -1. So if it is -1, then we have not got drop point. Then what I will do, I will simply reverse my entire array, that is from 0 to n-1. I also need to pass nums array to reverse the numbers in place. Then after that, I will simply return from here. Okay, so this is our first step and our edge case. Next one will be our step 2. Assume we have got the drop point. If that is the case, then find greater element than our drop point element. Correct, right? So for that, again, I will start from the right. So I will use for I equal to n-1 this time. Why? Because I want to check all the values from the right if it is greater than the drop point value. I greater than or equal to 0, I minus minus. Okay, then what I will do, I will check if nums of I, if this is greater than the element at drop point, then we got the number greater than the element at the drop point. Then what I will do, I will simply swap. So constant temp equal to nums of I. Okay, I will maximize this. So it will be nums of I, then nums of I will be nums of drop point value. Then nums of drop point value will be our temp value. This is how we swap two numbers, correct, right? So there is a easiest way, that is a one line way in JavaScript. So I will use that. So basically I will comment out these three lines. This is a traditional way. So you can simplify something like this, nums of I, comma. So I will use another array. So I will paste this in the both the places. I will copy this one. So basically what I will say, nums of I, comma, nums of drop point equal to nums of drop point, comma, nums of I. So this way it easily swaps two numbers in JavaScript. Now after this, once this swapping is done, I should simply break from this particular point. Okay, I will break. Now after this, the third step would be, I need to reverse the numbers after drop point. Okay, so basically I will call my reverse method. So I will pass drop point plus 1 because drop point has its correct value. So now I want to reverse the remaining numbers plus 1 comma till n minus 1, till the end of the array. Okay, so this is done. After this I need this reverse method, right? So I will say constant reverse, sorry, it should be reverse. So constant reverse equal to, so it will take the left pointer, the right pointer and the nums array. Okay, so basically I'm reversing the array in place. So for that, what I will do, I will check, I will iterate with using two pointers and I will swap the numbers. Then I will decrement the left pointer, I increment the left pointer and decrement the right pointer. That's what I'm trying to do. So while left is less than right, then what I will do, I will say nums of left. Basically I will copy this entire line. So this is basically swapping I'm trying to do. So I will say this is left, this is right, again this is right and this is left. After this I need to increment my left pointer and I need to decrement my right pointer. This way it reverses. With this change I will try to run this. Let's minimize this. If you see, it got accepted. Now I will submit my solution. There is some issue. So basically it says, so somewhere we have forgotten to pass the nums array, it seems. Yes, correct. So here we have forgotten to pass the nums array. So with that, let me resubmit it. I think in the earlier one I have passed. Yeah, here I forgot. So with that, we successfully submitted this solution. Okay. So this is the most optimal way where we solve this problem in O of n time complexity and O of 1 space complexity. That was in place. Okay. So hopefully I was able to make you understand the solution or the intuition behind this problem. So if that is the case, please consider liking my video and also subscribe to my channel, share this video with your friends. And if you have understood it well, please add that as a comment as well. Thanks for watching.